So, ladies and gentlemen, as chairman of the French group of IABSE and the organizing committee, I have the great honor and the pleasure to open the 40th IABSE Symposium and to welcome you in this Nantes Events Center. I thank IABSE for accepting the venue of this symposium in Nantes on the theme of tomorrow's megastructures. Popularized in the 60s as an architectural concept, a megastructure is referring to a very large man-made object, though the limits of precisely how large it is may vary considerably. This term could be applied to any especially large or tall building, but also to enormous self-supporting artificial constructions. This symposium will be the opportunity for the structural engineering community to share their experiences with today's megastructures and to present their visions of tomorrow's megastructures and more broadly, their prospect of future outstanding structures. I have now the pleasure to introduce Mrs. Christine Aurin, Vice President of the Department of Loire-Atlantique, who is in charge of education and educational policy and who is going to deliver a welcome address. Since his welcome address will be in French, we have prepared a translation of his speech, and yes, okay, and you will have the translation on the screen.
Merci. Monsieur le Premier ministre, Monsieur le Consul, Monsieur le Président de l'International Association for Bridge and Structural Engineering, Monsieur le Président du Comité d'organisation, Mesdames et Messieurs, au nom du Président du Conseil départemental, Monsieur Philippe Grosvalet, permettez-moi de vous souhaiter la bienvenue en Loire-Atlantique. Loire et Atlantique. Le nom de notre territoire exprime bien sa situation privilégiée à la rencontre de l'océan et du plus long et du plus sauvage des fleuves français. Cette situation est pour nous une grande chance, mais c'est aussi un défi permanent pour notre collectivité qui a la responsabilité d'entretenir et d'exploiter 4 300 km de routes et pas moins de 1300 ouvrages d'art. Parmi ces 1300 ouvrages d'art, nous avons la chance de compter le plus grand pont de France, le pont de Saint-Nazaire. Le pont de Saint-Nazaire, sous ses 3 356 mètres qui s'étendent de part et d'autre de l'estuaire de la Loire, passe de nombreux migrateurs, ainsi l'anguille qui fait des allers-retours avec les eaux intérieures via la Loire et la mer des Sargasses de l'autre côté de l'océan, mais aussi des pétroliers, les méthaniers et les porte-conteneurs qui relient le 4e port français au reste du monde. Sur le pont de Saint-Nazaire, ce sont pas moins de 30 000 véhicules par jour qui circulent, et pour tenir compte du flux inversé entre le matin et le soir, ce pont a été le premier en France à être équipé d'un système de gestion dynamique d'affectation des voies. Enfin, au-dessus du pont de Saint-Nazaire passent les avions Airbus, dont le plus gros avion du monde, l'A380, dont une partie des pièces sont construites ici, en Loire-Atlantique, dans 2 usines, l'une juste à côté du pont de Saint-Nazaire et l'autre à quelques kilomètres d'ici même. En remontant la Loire, nous parvenons aux 16 ponts routiers et ferroviaires qui irriguent la ville de Nantes et qui sont sous la responsabilité de l'État et de la métropole de Nantes. Un peu plus en amont se trouvent 2 autres grands ponts gérés par le département de Loire-Atlantique. Ce sont les ponts de Thoiret et de Mauves. Le premier, le pont de Thoiret, vous est peut-être connu. Son tablier a en effet totalement été rénové dernièrement au moyen d'une technologie de béton fibré ultra performant, le BFUP. Le second, le pont de Mauves, subira prochainement le même traitement. Enfin, encore plus en amont, aux limites de notre territoire, se trouve le pont suspendu d'Ancenis, qui a lui aussi récemment fait l'objet d'une rénovation. Pour une collectivité comme la nôtre, la gestion de ces grands ponts représente une grande responsabilité, comme nous l'a récemment rappelé la tragédie de Gênes. C'est aussi une grande fierté que de les entretenir et de les exploiter. À ce sujet, permettez-moi de remercier ici l'ensemble des personnes qui, au Conseil départemental de Loire-Atlantique, pilotent leur entretien et les gèrent au quotidien. Tous ces ponts relient le nord et le sud de la Loire, comme on dit chez nous, le Nord-Loire et le Sud-Loire. Vous aurez en effet peut-être l'occasion de constater par vous-même les différences qui marquent les paysages de part et d'autre de la Loire. Au nord, les toits des maisons sont gris, faits d'ardoise, et aussitôt franchi la Loire, ils sont rouges, recouverts de tuiles. La couleur des toits n'est qu'un petit exemple de la diversité de notre département, de la Loire-Atlantique. Cette diversité, c'est notre richesse la plus précieuse. Elle est l'expression de notre situation de carrefour historique entre plusieurs régions, la Bretagne, la vallée de la Loire, la Vendée et le Poitou. C'est aussi une ouverture du monde que nous souhaitons le plus large possible. Ainsi, la Loire n'est pas une frontière. Au contraire, elle est la colonne vertébrale de notre territoire, et cela a été possible parce qu'il y a très longtemps, des hommes et des femmes ont osé franchir la Loire à gué ou au moyen des bacs qui existent encore aujourd'hui. Et cela est aujourd'hui possible car des générations d'hommes et de femmes comme vous se sont succédés au fil des siècles pour imaginer et construire des ponts en bois, en pierre, en béton ou en métal. Les ponts relient les territoires et surtout, et en conséquence, ils relient les hommes et les femmes. La Loire-Atlantique n'existerait pas sans ces ponts, elle n'existerait pas sans les bâtisseurs que vous êtes, et en cela, permettez-moi, mesdames, messieurs, de vous en remercier bien sincèrement. Aussi, je vous souhaite de bons travaux tout au long des 3 jours qui viennent, et j'espère qu'ils vous laisseront quelques répits pour découvrir Nantes et la Loire-Atlantique. Je vous remercie. Thank you.
I thank you, Mrs. Orin, for your welcome address and your kind reference to engineers who built and maintain bridges. Now, I welcome Professor Fernando Branco, President of IABSE. So, Fernando.
Dear colleagues, first, in the name of IABSE, I want to welcome all of you to Nantes. Soyez les bienvenus à Nantes. Faut faire. OK. Cette conférence, this conference is organized by the IABSE French group and the Association française de génie civil. Et pour commencer, sorry, and to begin, it's difficult to speak with 2 languages. And to begin, I must refer to special names. One is Bruno Godard, that is the chair of the organizing committee, and the other is Christian Cremona, is there, that is the chair of the scientific committee. I'm sure they had a lot of work, but the final product is quite good. Okay, thank you very much in name of IABSE. The conference has a nice theme. It is called Tomorrow's Megastructures. And there are 2 words, tomorrow and megastructures. Thinking about tomorrow, what I can say is we engineers like to build always higher, longer, stronger. These are the 3 main mottos of our profession. And in this conference, we are going with the World tomorrow to discuss the new adventures, let us say. We are facing new things that are brought by the climate changes. How would that influence our new structures? We are going to have to change our industry in a more industrialized industry. We need to begin to think in a more kind of fabric construction. And above all, the thing that are the top in our evolution is the digital. The digital, as you all have seen, is entering with our structures, and we need to adapt to that, and we need to improve our conceptions with the word digital. This is the word tomorrow. In terms of megastructures, well, we engineers, I would say, we know how to design with safety for the heaviest loads, for the earthquakes, for the hurricanes. But suddenly we had accidents like that one that we had in Genoa a few weeks ago. What does this mean? It means that our bridges are safe, are not safe. I'm going to say that our bridges are not safe. And what does this mean? This means that our structures, as soon as they are built, they begin to degrade. All of us, we know that there are the carbonation problem, the chlorides attacks, all those things. And if we want our structures to be safe, we need to have maintenance. It is a very important word, but unfortunately the society does not know that word. And the society, when they look at our structures, they always look at them as if they were eternal, but they are not. We know that, but they don't know that. And the main lesson that I think we can get from the accident in Genoa is that we need to be more in contact with the society. Perhaps you don't know, at least some of you don't know, the symbol of IABSE, this symbol. Do you know what it means? It was a symbol that was proposed by our colleagues from China and Japan. At that time it was from Japan, but the symbol is the same in China and in Japan. It's the symbol of human being. Okay? So that is something, it's the message that I leave with you. We engineers are quite good in our professions, but we need to speak with the society to tell them also our problems so they better understand and they can be more in contact with us. By the way, we have a special session about the Genoa Bridge in this conference. I'm sure that all of you will be there. And so basically are these ideas that I just leave with you, and now please enjoy the conference. Thank you very much. And I go on. I don't leave because now we are going to enter with the awards ceremony. And now I begin to read. IABSE, as the members of IABSE already know, has a lot of awards, and we use these symposiums to give the awards to several persons and even structures. So the IABSE Awards publicize to the entire structural engineering community, industry, and general public the excellence and value of our work. This is done by honoring projects, careers, advances, and services. The first award that we are going to present are the honorary membership that is presented to an individual member for his or her exceptional great service to the association. We have two members that are honored with this award. The first one that we shall honor is Professor Lennart Alfgren from Sweden. And may I please call Professor? Professor Leonard Elfgreen is Emeritus Professor of Structural Engineering and Building Materials at Luleå University of Technology since 2009. He was a research engineer at Swedish National Testing and Research Institute and Dean at the Faculty of Engineering between 1990 and 1997. Leonard Elfgreen was involved with IABSE since 1970 and was the chair of the scientific committee at the IABSE conference in 2016 in Stockholm. IABSE confers the honorary membership to Leonard Elfgreen in high appreciation of his outstanding and dedicated service to the association. Our second honorary membership award goes to our long-standing member from India, also former Vice President, Dr. Bindan Chandra Roy, among friends known as BC Roy. And may I call it him, please? Welcome. I'd like to say, BC Roy has been one of the pillars of the worldwide structural engineering community for years, including within IABSE, where his leadership and example has been an inspiration to many. He has worked on several notable projects, including the Kolkata Metro and the Nivedita Setu across the river Hooghly in Kolkata. BC Roy has been an IABSE member since 1990, fellow since 2003, member of the Technical Committee and Working Commission 5, and a former vice president. He was the scientific committee chair of Kolkata Symposium and a member of the scientific committee in Delhi, Phuket, Seoul, Antwerp, Dubrovnik, Chicago, and Cairo. He knows IABSE better than me. Now we pass to another award, the International Award of Merit in Structural Engineering. Underlines the importance of the work done by engineers. So it's an award for the career. It is conferred by IABSE for outstanding contributions in the field of structural engineering with special reference to their usefulness and society. Our awardee this year is Mr. Tristram Carfry. May I please call him? It is my pleasure to present the International Award of Merit in Structural Engineering to Tristram Carfry from UK in recognition of his outstanding contributions for more than 50 years to structural engineering, including several span world records and outstanding structures, and his sensitivity to bring structural engineering design close to art and poetry. Thank you. Now we pass to the IABSE Prize. It honors a member early in his or her career for an outstanding achievement in the field of structural engineering in research, design, or construction. The prize is presented to individual members of IABSE, 40 years of age or younger, with a money prize of 2,500 Swiss francs. May I please call Professor Guy, that is representing the awardee, that is Teng Wu. He's here, not in that front. It's not so young. Now, Outstanding Paper Award. The Outstanding Paper Award is given each year to the authors of papers published in the preceding years' issues of IABSE journal, SCI, encouraging and rewarding contributions of the highest quality. The Outstanding Paper Award is presented in two categories: scientific paper and technical paper. The former relates to R&D and the latter to projects. This year, too, the awarding committee was chaired by Andres Lampropoulos from UK. I please call upon Dr. Andres Lampropoulos, okay, together with the authors, Professor David Nethercote and Dr. Panagiotis Stylianidis, to please come to receive the award of the scientific paper, whose title is Considerations for Robustness in the Design of Steel and Composite Frame Structures, published in the number of May of the journal 2017. The second Outstanding Paper Award is presented in the category of Technical Report to Dusan Radojevic and Kate F. Kirkwood from Canada. They are here. Okay. They are not here. So may I please call Mr. Scott Alexander to receive the award in the name or on behalf of the authors. The paper that was awardee has the title New Old Bridge Renovation of the McDonald's Suspension Bridge, published in SCI February 2017. Now it's the IABSE Outstanding Structure Award. This is the highest, let us say, the highest award of IABSE. It's the most important structure being built in the world during the year. It's one of the highest distinctions awarded by IABSE and recognizes throughout the world some of the most remarkable, innovative, creative, or otherwise stimulating structures. Sustainability and respect of the environment is also an important factor. This year, we have the Yavuz Sultan Selim Bridge, third Bosphorus Bridge in Istanbul. It's considered as the future of the transportation and commerce for Turkey, linking Europe and Asia, by its major importance and its symbolic situation between the two continents. The bridge has become an iconic structure and a landmark of Istanbul region and Turkey. May I ask Naim Hussein, please? He is the chair of the award commission. And the awardees, may I invite now Mr. Samet Sain, Mr. Thierry Delemont, Mr. Vincent Deville, Mr. Michel Virloger, The laudation of this structure is the Yavuz Sultan Selim Bridge exemplifies an outstanding concept of combining the advantage of suspension and cable-stayed systems, as well as the design and construction with the most advanced technologies in structural engineering. It epitomizes a holistic approach of engineering and architecture. Within this award, we also refer the three finalists. The first one is the viaduct over River Almonte in Cáceres, Spain. It's the high-speed railway between Madrid and Extremadura, crosses over River Almonte through a 996 meters long viaduct with a great 384 concrete arch, which make it the largest HSR arc bridge built to date. May I call Mr. Pablo Jimenez, Mr. Guillermo Capellan, Mr. David Arribas, and Mr. Pedro Cavero de Pablo. The other two finalists are the Queensferry Bridge in UK and the Circle Bridge in Denmark. Unfortunately, we do not have here the representatives, so we shall just give congratulations to them, and we give the awardees to the chair.
I'm taking this on behalf of the Queensferry Crossing people. I just happen to have a little bit of interest in it, and I will give it to the audience.
Thank you. And it's closed. And with this, we closed the awards ceremony. Thank you very much.
So I have now the pleasure to introduce the chair of the IABSE Foundation, Tobias Zordan, who is going to present the IABSE Foundation and a charity project for the construction of a footbridge in a remote village in Uganda. So please, Tobias.
Good morning, ladies and gentlemen. Thank you, Bruno. Thank you to the organizing committee and to IABSE for giving the foundation this space. I'm very pleased to be here today on behalf of the foundation and to have the chance to present to you our latest achievement. It's a bridge. It's a bridge in Uganda. It has quite an interesting story, and I hope you will enjoy the story, and you'll be able to share more challenges in the future with us. A few words about the foundation. Foundation is a totally independent and non-profit institution which is run on a fully voluntary basis. We receive funds and we give out funds, so as much we receive, as much we are able to provide. And the goal is to spreading the knowledge of civil engineering and promoting education programs and self-constructions in the most disadvantaged areas of Earth. The challenge last year was to build a footbridge in Uganda, a footbridge with a very high symbolic value and meaning. A bridge can reunite two separate parts of a village, which is cut by a river, which is flooded by, during many, many days of the year, more than 4 months. Of course, that creates problems to locals, and we will see what kind of problems in a while. The location is Uganda, you can see in the map, and the village is really a very remote village with about 4,000 people and quite a large community of children. The partners of this venture. The project was proposed by Bridges to Prosperity, and we took the advantage. It was a very interesting project. IABSE is, everything about bridges, and so we thought it was a fantastic occasion to have the chance to build a bridge. So we took this challenge. We decided we wanted to be partner in this venture, and we shared the prize with Rambo. That was the other partner that paid for 50% of the cost. But we are IABSE. We want to be not just a financial partner. We are bridge engineers. We wanted to be a technical partner. And more than the money, we wanted to put effort. We wanted to put knowledge, strength, passion, and our sweat. So IABSE Foundation doesn't have any staff, so we needed to partner with some engineering companies. And these 3 companies, Polina from Italy, Shimeta from Austria, and Bridgewitz from Turkey, are companies that put their sustain the cost to put up a team of volunteers, fully volunteers. Then the journey, we started from Italy, Austria, and Turkey to go to Uganda with a long journey. We landed to Kampala, which is the capital and the closest place to the venue. The background, what we found a village that was separated in 2 parts. A lot of children and locals were not allowed to healthcare facilities and schools for a big part of the year, and especially during the rainy seasons. You see here some short movies, a lot of enthusiastic boys, a lot of expectations to see what we could do, and if finally they could get a bridge that could improve the economy and the social relationship of the local community. The project was provided Bridges to Prosperity. This is quite a standard project. Of course, we are engineers, so the project has been double-checked, and we thought it was very simple, very cheap, but also a reliable one. And we decided we wanted to go for it. The most important part, the team of volunteers. These guys are engineers, and they decided to go on site and to put everything they had in order to get to the final results. Young people, a lot of energy, a lot of enthusiasm under the flag of IABSE. Very good organization on site provided by Bridges to Prosperity. You can see here some of the people involved. So general manager, manager for logistics, and then a site engineer, a local site engineer, and a local foreman to check everything was going on there. The local community played a fantastic and key role in the construction of the bridge. They showed very high motivation. They were trained before the beginning of the construction. They got a period of training, and on Saturdays, the worksite was fully open for the local community to come and enjoy, and of course contribute. So before the arrival of the IABSE group, some works have been done and preparatory works for the foundations and abutments. You can see a fantastic detail of the cable saddle there with the truck wheel. So everything was full of energy and full of enthusiasm. Then the IABSE team arrived, and with the local team and Bridges to Prosperity and the Rumble team completed the foundations and the abutments. And really our engineers worked as carpenters to prepare all the details, to lay the cables, to bend the bars, to prepare the fences. And I have to say I'm very proud of it. We started from the beginning, and roughly in 1 month, we got to the end of the completion of the bridge. You see here some phases. So I have to say that I'm very thankful to the team that worked on that. And we finally got the opening of the bridge with the dynamic test of the structure. Very risky, actually, because we made some measurements about the frequencies, and we said, we were very concerned when we saw people jumping, dancing on the bridge. You see here this guy, Serjan, he is here. I think what better than having from a person that put his effort and his sweat on site a few words. So, Serjan, I think everybody is happy to see your face. IABSE is made of people, of volunteers. So I think maybe just a few words, you can explain your experience and what you got inside after this venture.
Thank you, everybody. So we were these 9 engineers, international engineers coming from very different backgrounds, and we all met in this very far place of the world to help the people that don't have the same kind of infrastructure that we have in Europe. And during the construction, we really put in a huge effort. We worked long hours under the rain, under the sun, but you can never get tired when you feel that the hundreds of eyes of the children are watching your every move, every single step. And also we were so impressed about how much the local community wanted this bridge, because they were working much harder than us under the rain, and instead of complaining, they were just dancing about it. So it was really impressive. And this bridge is, not only about crossing a river, but it's also crossing some barriers, social, economical, and language barriers between us and the local community as well. And in the end, we felt we are not very different from them. So in this conference, I think for a couple of days, you'll hear a lot of bridge technology, but sometimes a bridge is just a safe way to home. So I would like to thank IABSE Foundation for making this possible for these beautiful people living in this specific place of the world. And I can assure that it worth it every penny. So I encourage you to continue these kind of projects. Thank you.
Okay, Serjan, thank you for your words. I think that they've been very important to all of us. You mentioned a very important thing. I hope that you will continue doing this. Okay, of course we will. We have plans for next year. This is the first, I guess, from my knowledge, this is the first bridge built under the IABSE flags. So this is our bridge, this is your bridge, This is the bridge of all the members of these associations and of all the volunteers. We want to continue this. We have plans for next year. We would like to meet yourself again in September with another achievement. But of course, we have to thank the volunteers, and you see their names from IABSE. They always were wearing IABSE t-shirts and IABSE flags everywhere. But more than that, we need you. So we need every single contribution is very important. So please help us donating big money, little money, whatever you can, your time, everything is important. I hope we can continue. I hope you can help us. Thank you very much.
So thank you, Tobia, for your presentation. And André Orsesi, Secretary of the Scientific Committee, is now presenting to you some main features of the scientific program. So please, André.
Good morning, ladies and gentlemen. It is my pleasure, and honor as Secretary of the Scientific Committee, to welcome all of you today in Nantes to the IABSE 2018 Symposium. With Christian Crémenat, Chair of the Scientific Committee, we have exchanged during this last year with many of you experts in the field of civil engineering to come up with a very exciting scientific program. The presentations that you will see have a huge range of diversity across a range of disciplines. They involve consultants, contractors, owners, researchers, and practitioners who will have a great opportunity to share their knowledge and experience. As it was said, the theme of the symposium focuses on tomorrow's megastructures and megaprojects. During these 3 days, it will be the world's meeting place for discussing of synergies, innovation, and challenges when it comes to design, build, inspect, monitor, maintain, rehabilitate, and then preserve civil engineering structures that are so crucial to the functioning of our communities and societies. It is crucial as structural engineering directly governs the strengths, integrity, safety, durability of structures by marrying visual appeal, practical function, and budgetary resources in a way that satisfies all needs. We are fortunate and delighted to have 6 prestigious keynotes, 1 today, 2 on Thursday, and 3 on Friday, with internationally distinguished speakers who accepted to present some of the megastructures presently being built. We also have had an enthusiastic response from the engineering community with over 500 abstracts received and finally more than 300 oral papers to be presented in 8 parallel sessions during these 3 days. The Scientific Committee, and we, Christian Crémenat and myself, we would like to thank all the experts who accepted to join this committee and to peer review the scientific submissions. This committee has taken great care in preparing a high quality and varied program that will feature the latest developments and ideas related to megastructures, megaprojects, and more largely the management and preservation of structures. Concerning the awards, there will be some prizes for speakers registered as young engineers. A jury will select 2 contributions from young authors born in or after 1984, and each will receive a prize that will be presented at the closing ceremony of the symposium. Tonight, we will also have a special session called My Thesis in 180 Seconds. Some PhD students have been selected to present their research work to a multidisciplinary jury. The challenge, make your thesis topic easily understandable with the help of only 1 slide. Prizes will be awarded to the top 3 presentations, also during the closing ceremony. So do not miss tonight this great event that will take place in this auditorium. To conclude, we hope this 3-day program will be memorable and beneficial to all our honored participants who have made this event a success. Take the opportunity to present, listen, learn, debate, network during this week. So what are we waiting for? Let's start talking. Thank you.
Okay, merci André. I have now the great pleasure to introduce Jacques Combeau, former president of IABSE, that will moderate the first keynote lecture of this symposium.
Thank you, Bruno. The first keynote speaker of this 2018 IABSE Congress in Nantes was graduated from the Polytechnical School of Cairo University as civil engineer in 1972. He joined the Arab Contractors Construction Company and supervised the construction of bridges, tunnels, power plants, government facilities, and restoration of historic monuments in Egypt and Saudi Arabia. In 2001, he became CEO and chairman of the board of directors of Arab Contractors, which is, as you know, one of the largest and major leading construction company in Middle East and Africa. He serves also as director of the Civil Engineering Studies and Research Center at the Faculty of Engineering of the Cairo University and as trustee of the French University of Egypt. In 2013, he became Minister of Housing in Egypt and was then appointed Prime Minister of Egypt from March 2014 to September 2015 by President Abdel Fattah al-Sisi. Ladies and gentlemen, I have the pleasure and we have the great honor of welcome Mr. Prime Minister Ibrahim Malab, who is going to talk about mega project towards Egyptian construction renaissance. Mr. Malab, please.
Bonjour, chers collègues. On m'a dit de parler en anglais, mais je commence en français pour vous remercier, le groupe de IABSE, groupe français de IABSE. Je vous remercie vraiment de me donner cette chance pour présenter devant cette élite mes collègues chevronnés, mes collègues talentueux, ce que se passe en Égypte pour les grands projets. Merci, et je dois switch to the English. Well, mega project in Egypt, and I am going to concentrate on to highlight on three projects. One is a cable-stayed bridge, the other is 2 tunnels under Suez Canal, and a landmark, really, comme on dit, un projet phare, c'est the Grand Museum of the Grand Egyptian Museum. The revolution in January 2011 took its toll on the Egyptian economy, resulting in a slowdown that was reflected in deterioration of the real GDP growth rate and the increase of unemployment. Furthermore, total investment witnessed a material downward trend, and the country's foreign reserves were depleted significantly. And this shows how really the employment increased after the revolution and the collapse of the Egyptian economy. Consequently, the rating agencies downgrade Egypt's sovereign rating by around 6 notches during the period from January 2011 to July 2013. You can see how also this downgrade. We find that the only way to energize and to activate our economy is going for mega projects. During the last 4 years, mega projects in Egypt are diversified. We started with a very big project, is the doubling of Canal Suez. We dig a new canal parallel to the existing canal, and millions of dredging meter cube. And during this period, we used 22 dredgers, and we achieved this project in 1 year. The second one is electrical power station plants. We add to our grid 25,000 megawatt in 4 years, and I think this is the biggest project in the field of electrical generation. Affordable houses, 1 million units are planned to be added. We achieved till now 650,000 units. New roadways, 7,000 kilometers are added to our network in 4 years. And this also, I think, it's very remarkable project in Egypt. Reclamation of the desert. We add 1 million acres to be reclaimed in the desert. New cities, 14 new cities spread all over Egypt. And a new administrative capital is now under construction. That means that really Egypt now is a very big site, working 24 hours, 7 days per week. Fisheries, we established a big fishery, 3,000 acres in north of Egypt. Restoration of heritage and monuments. Also, Egypt is full of heritage and monuments, and now we start to restore it. Mega project in Egypt, maybe Road al-Farah cable stayed bridge is a remarkable bridge which we can really present, and the 2 other tunnels under Suez Canal, we have to highlight those, and this is a Grand Egyptian Museum. Our motto is quality, equal, should fit to purpose, and this was the concept of our thinking. Technical aspects, economical aspects, formal aspect, and environmental. Those are the 4 factors we worked, because we don't have really time, and it is a question of how to select, during this, the most optimized, the most economical project, and to start immediately construct. Design condition, functions, client wish, budget, resources, location, construction, give us the design aspects. Design alternatives, always we have to think about the value engineering and to choose the most really optimized project. Always there was a committee from the object design team, architect, client, contractor, project, and management. This was a permanent team working to select the most economical project. It gave us the evaluation of alternative and the decision making, and decision was taken really in a very short time, and this was the big challenge. Road al-Farah corridor is a corridor, is 2 stages. First stage, we have now we have to go to Egypt now. Okay, sorry. Well, this corridor is two stages. The first stage is 29 kilometers of roads. This is linking the west and the east of Cairo. The first stage was an elevated road, 29 kilometers of roads elevated, with 9 small viaducts and 12 underpass and tunnels. This was sector 1. The sector 2 is 5 bridges. The stage 2 is 5 sectors. The first one is a bridge, precast beams. Second one is a cantilever carriage pre-stressed bridge crossing the Nile. Third one is also a viaduct crossing an island. The fourth one is a viaduct crossing a very congested area in Egypt, is Shubra. The cable-stayed bridge is sector 4. This cable-stayed bridge really is very special because it is the first cable-stayed bridge crossing the Nile. The bridge has a semi-floating bearing system in the longitudinal and transverse direction. The bridge is floating in the longitudinal direction in which the wind and the seismic loads are carried by cables and towers, while the bridge is supported transversely by bearings to carry transverse loads due to seismic and wind loads. The side spans of the bridge has concrete box section to work as a counterweight to the main spans under live loads, although its arrangement is not usual for such side span min to span ratio of 0.4. In construction, due to the bridge heavy cross section, which is constructed using a rigid temporary force work, which was specially designed and constructed for supporting those heavy loads. The bridge also, maybe it's one of the widest bridge in the world because the wide varies from 64 up to 88 meters. This is the height of the bridge pylons. It was constructed by climbing form. Every segment is 4.5 meters. The 95 height 2 pylons have hollow concrete cross section. The construction of pylons was carried out using self-climbing formwork. Each pylon leg was divided into 20 casting segments with height of 4.5 meters for each segment, with 6 platforms, as is considered as the heights of this construction type. And the figures shows respectively the pylon cross-section segment and adopted self-climbing formwork. This is the pylon head. This is a steel pylon head. The top cable anchorage are implemented in steel boxes units that work as the inner shuttering of the pylon head. This was fabricated outside in workshop, and because the angle and the accuracy, maybe the tolerance is almost zero tolerance. And this is really the pre-assembly of units for geometry control. The pylon head erection After assembling it in the pre-assembled workshop, we are transferring it to the site and starting the erection. The deck segment in main span, 20 segments of steel composite open section of 14-meter length. The segment height of about, every segment height was about 180 tons. Precast concrete spans are arranged on segment top, and this was also pre-assembled in pre-assembled workshop. Then we have to transfer it by barge and to lift it to the site. The steel deck anchorage. This is the steel deck anchorage. Deck anchorage fabrication, consideration of sag angles and cables and final geometry of the deck, fully tested welds using ultrasonic. The main span deck segment pre-assembled in the yard. We are assembling 3 segments, and all the holes are fitted at the workshop. This is how we are assembling the deck segment in the yard. The cross beams, then moved. The other segment is coming. This is the second segment, because this is very accurate how to fit, that the holes are, when we are assembling it as a site, should be accurate 100%. And the third segment is coming. Then we are lifting it by cranes. Putting the segment on the barge. And going to the site to be assembled, the site. We have used 2 launching girder for each segment. Every launching girder, the capacity was 90 tons. This is the erection of the steel segment using the launching girder. Then we add the precast slabs, and then we are stitching the slab. The construction of the deck inside span, it was an RC deck box section inside span. The total width varies from 65 meter to 88 meter. And this is the heavy shuttering and scaffolding for the deck span. This is concreting of the side span. This shows the construction of the pylon. The main span was 300 meter, and 2 side spans 120 meter. This is a semi-floating bearing floating in the longitudinal and fixed in transverse direction. We have used what we call dumpers, spacer laid with boreholes, shear connection, a threaded pre-stressing bar spacer with bar holes was added in the pylon. And this is the 12 viscous dumpers in the pylon. Those for getting all the stresses coming from transverse and seismic stresses. This was the erection of the first cable, and now it is, I think, they start the erection of the second cable now in Egypt. Figures, total piling length, the diameter 2 meter and 1.5 meter, we have used 8 kilometer of piling and 15 kilometer of 8 kilometer of 2 meter piling diameter and 15 kilometer of 1.5 meter diameter. Total structure steel reach 10,000 ton. Total concrete volume 48,000 meter cube. The total reinforced steel 19,000 ton. The total stay cables 1,800 ton. This video is from the, okay. Going to another mega project. You know that in Egypt we have the Suez Canal is between the west and the east part. The east part is Sinai. The west part is, and this is, Sinai is in Asia. And always we have to cross the Canal Suez by bridges. And we construct a bridge, cable-stayed bridge over Canal Suez, but we need 4 tunnels we are constructing now, 4 tunnels under Suez Canal. Suez Canal is, for Egypt, is very important, not only for Egypt, but for all the world, because the location of Egypt is in the center of the world, linking the Red Sea with the Mediterranean, and the ocean, the Indian Ocean with the Atlantic Ocean. That means this is a very important location in the world. We thought about those 4 tunnels, and at the same time we are creating an economical, logistic, industrial zone in Egypt east of Suez Canal. The project purpose to establish access route started from the west of Egypt to the east of Egypt, direct, without crossing, without any obstacles. And to connect the international coast road with the west side of Suez Canal to reduce distance by 100 kilometers to cross canal according to current situation, and serve the East Port Said and investment-free area, providing new investment opportunities and accelerating the urban area in Sinai, encourage the citizen in the East Delta to be transferred, because Sinai is representing almost 6% of the area of Egypt, but there is no inhabited in Sinai. It's more or less than 500,000 the population. Egypt is 100 million. That's why we want to encourage people to go and to live in Sinai. Technical project challenge: tunneling is silty clay layers without affecting the navigation in the Suez Canal. This is very important, that we are constructing the tunnel without affecting the traffic navigation. The tunneling boring machine modification due to dissolved methane gas. This area is full of methane gas layers, and transfer the material. It was another challenge, how to transfer the material from the west to the east. Soil condition. We can see that this is the worst soil condition in Egypt is this area. The clay layer, very, very soft, highly plastic clay, 42 meters thick, with sand penetration values of less than 5. The sand layer, very dense quartz sand, 70 to 100 meter thick, and clay layer, hard silty clay, less than 3 meters thick, with sand layer 2. Groundwater level above mean sea level, and this area is chemically very aggressive. We start to make a kind of soil improvement, and we have to face the challenge methane gas, because the risk was very dangerous, or explosion, or fire risk and gas flooding. And to mitigate the risk, working group of all parties, we establish a review applicable codes and standards, and we investigate to define the gas hazard and options and modification in the tunneling boring machine. This is a project. In the middle, there is the North Tunnel, South Tunnel. Then we construct the launching, a launching shaft in the east side and a reception shaft in the west, plus a cut and cover area and an open security entrance. In figures, the road tunnels for Port Said, the diaphragm wall, the west 510 meters, the east 430 meters under Canal 0, overall 940 meters of diaphragm wall. Launching, receiving, and receiving shaft, the west 40 meters, the east 100 meters, and the overall 150 meters. And the tunnel itself, by the tunneling boring machine, was in the west 1 kilometer, almost 1 kilometer, 93 meters, and the east 1 kilometer, 150 meters, and under Suez Canal 658 meters, and the total is 3.8 kilometers. This is a vertical alignment, and we can see that we are under the bed of Suez Canal, 24 meters under the bed. This is a cross-section of the tunneling machine. The diameter of the tunnel is 11.35 meters. We used 14 diaphragm wall equipment. We used forming concrete equipment 48, excavation and backfilling equipment 56, joint equipment 76, soil injection equipment 8, mechanical works equipment 59, and overall there was 261 equipment in the site. This is the east launching shaft, and we can see that is due to the very bad soil. It was an arched shaft. This is the launching shaft. The TBM factory test, it was the tunneling boring machine. We start to assemble it at the site. This is when we finished, and this is the breaking out for the machine. This is a segment factory. The area of the factory, it was a huge factory, 10,000 meters square, production rate 15 rings per day, and the area of storage yard to 20,000 meter cube. Segment factory. This is the road deck. It was precast, and now we are fixing the road deck now in the tunnel. This is planned to be open mid of next year. This is the cut and cover and diaphragm and the struts. This is the cut and cover area. Major quantities, the tunnel boring works 770,000 meter cube, excavation work 1,500,000 meter cube, soil improvement work 2,093,000 meter cube, diaphragm wall 550,000 meter square, concrete works 1,002,500 meter cube, reinforcement work 105,000 ton, precast concrete rings 129,000 meter cube, road deck concrete works 40,000 meter square. From this figure, you can imagine the challenge, because we started in the year first at the beginning of 2016, and almost the tunnel is structurally finished. Last but not least is the Grand Museum. This is the Grand Museum on the plateau of the pyramid. It's far from the pyramid 2 kilometers. And really, the architecture thinking is, it was a competition, and this was the first prize. The architect design of the museum was based on the concept of pyramids, formation in both elevation and plan views. The main building footprint was planned based on the pyramid's plan grid lines. This is a relation between the structure and the monument, the pyramid. The site ranges regarding the three pyramids starting from exact point at north and west intersect with each forming of the building footprint. This is the idea, how the projection in elevation and plan intersect to create the location of the museum. There is an entrance courtyard. The entrance courtyard contains long span opening, mesh roof, primarily for shading. The entrance is located at the heart of the master plan. And if we look to, there is 27 components, but the structure itself is 1, 2, 3. Those are the structure, but the other are landscaping. The structure system of the roof is composed of long span steel trusses rested on movable elastometric bearings on reinforced concrete corbels, as shown in figures. The truss cross section are made of box steel section with dimension ranges from 40 centimeter to 80 centimeter and thickness up to 9 centimeter. In the entrance, we put the statue of Ramses. And there is a history for the statue. This was relocated from a very congested area to the museum. And this is another project, but it will take a long time. This was diffused by more than 70, the relocation and the transportation of the statue. It was diffused by 70 international television. This was the place, the original place in a congested area near the railway, but the pollution and the congestion forced us to relocate it. And we transferred this statue in the year 2006 to the site of the museum. This is really, it was, we took more than 1 year for the safe transportation of this statue. And this is in the year, this year we move it from the storage in the museum to the final place in the entrance. And we considered him as a king, and it was a small parade and festival to receive the King Ramses in his final place. This is the main place in the museum. This museum is planned as a museum of art craft of ancient Egypt, described as the largest archaeological museum in the world. The museum is under construction and is scheduled. The full structure is finished. Now we are in the finishing and the landscaping and electromechanics. This is the main building roof, which I described, the steel trusses. Is the main building roof. Gallery roof. Over the museum and conference center, a concrete folded plate roof together with external shaded void and internal ceiling void fill the roof volume, as this is shown in the photos. The main building structure system consists of steel beams grid with I-beam cross-section. The main beams are supported by the main trusses of the roof, while the secondary beams are rested on the main beams. This is the ground stairs. The ground stairs wall from two sets, and the people are going to sit it on the steps, and they can, from the steps, look to the pyramid. This is the facade. The structure system of the pyramid's wall is comprised of vertical steel grid of box steel sections aligned in the diagonal direction and supported on a reinforced concrete wall as shown in this figure. At the entrance opening, mega steel panels are used to support the facade cladding. During the construction, the fixation of steel diagrading in concrete wall was followed by mounting the stone panels. Those are transparent stone. In the sun, it will be transparent. In the night, it will be lighted behind the between the steel trusses and the facade. At the same time, we have a big workshop in the museum for the conservation, and there is a conservation center of all the monuments are going to be exhibited in the project. There was a very strict environmental strategy in this project. Conclusion. We really achieved our goal. The improvement in the Egyptian economic indicators after downgrading now triggered and the rating agency to upgrade the sovereign rating of Egypt. And the rating agency, if you compare before, in the red, it was in 2013, and the green is 2018. That really mega project. They energize, they activate, they put life in the Egyptian economy. Thank you very much for your listen. Thank you very much.
Thank you very much, Mr. Prime Minister. I think that we could have listened to you for hours and hours.
Yes.
It was a very nice presentation about these huge works which have been undertaken, which are ongoing or achieved in Egypt, and it was really very interesting. I don't know if we have some minutes, maybe 1 minute for question, if any. Otherwise,
Thank you.
thank you very much.
Thank
Is there any question? It's difficult to see.
Michel Cahan from CETEC Engineering Consulting Company in France. Thank you, Mr. Prime Minister, for this fascinating presentation of mega projects. By the way, I'm glad that a civil engineer can be in one country in the world appointed as Prime Minister to enhance large projects and leave a trace in history. Just a technical question. I was curious about how you actually mitigated the risk of gas inflow while boring the tunnel below the canal.
Yes, this is a very important question. By daily analysis, by safety equipment, and by some modification in the TBM tunneling boring machine. We modified the tunneling boring machine. It was Herrenlicht. They came and they modified it, and it cost a lot, really, to add some devices to protect people from this gas. By the way, you mentioned about civil engineering and Prime Minister. Believe me, when I was appointed Prime Minister, it was a very dark period in Egypt, but with the project management, I success. Really, the civil engineering, believing in his project management, how to manage a site, if really with his experience, he can manage a really big country like Egypt. Thank you very much.
It is undoubtedly a great example of what could be done and could be managed between politicians and engineers.
I say always I am an engineer, I am not a politician. Thank you.
Mr. Prime Minister, please allow me to offer you this book on behalf of the organizing committee of Nantes, of IABSE Nantes 2018.
Thank you very much. Thank you.
Thank you very much. Well done.
So before ending this opening ceremony, I would like to make a short presentation of the European Year of Civil Engineers. So I'm going to deliver a message of ECCE, which is the European Council of Civil Engineers, which supported this conference, and which was created. Yes, which was created in 1985 out of the common concern of the professional bodies for civil engineers in Europe, that the civil engineers working together across Europe could offer much more to assist Europe advance its built environment and protect the natural environment. So ECCE has 23 member country organizations extending from Portugal to Georgia and from Estonia to Turkey, and 6 associate members. And it is associated with 8 other international engineering organizations. Last year, ECCE decided to designate 2018 as the European Year of Civil Engineers, in combination with the 200th anniversary of the UK Institution of Civil Engineers. During this year, ECCE wants to reinforce the fundamental role of civil engineers in society in improving the standard of human life from the old year until now. We accomplished this through many different types of projects, including dams and reservoirs, water distribution and treatment facilities, road networks and bridges, foot bridges, rail networks, energy generation and distribution facilities, but also stadiums and cultural and social facilities, and many others like airports. Finally, ECCE wants to stress the pivotal role that civil engineers will play in addressing the challenges that will face society in the future, including rapid urbanization, climate change, and the digital revolution. I hope this has given you a useful introduction to this year EYCE, the European Year of Civil Engineers. So it's time now to move to some main features of the organization of our symposium. First, I would like, of course, to thank our keynote lecturer, former Prime Minister Mr. Ibrahim Malab, Mrs. Christine Orin from the Department of Loire-Atlantique, and also I would like to mention Mr. Giver, which is the Swiss Consul of Nantes, and who is present in this auditorium. Of course, I would like to thank all our sponsors and the supporting organizations. And I'll give you now some final information of the organization and of this event. So please note that the two following important changes in the program of the symposium, with the Bentley session, Better Bridges from Beginning to End, presented by Lee Tanase, will be moved and will take place on Thursday in room J from 12 to 12:30. And the second change is the addition of a special conference entitled A Report on the Genoa Bridge Collapse, Background and Apparent Causes by Fabrizio Palmisano, the Politecnico di Bari. And it is supported by the TG 5.1 of IABSE on forensic structural engineering. Then would like to mention that on Wednesday, so today, from 19 to 22:30, the welcome reception will be for the Machine de Lille, in Les Machines de Lille, so in the island of Nantes. And the meeting is in front of Les Machines de Lille. So you have to go by foot or by tramway to the entrance of this big building. So you have a pass in your bag, and you can take the tramway at the station Duchesse Anne and get off at the station Chantier Naval. And it's just close to this station. And for the return, I would like to mention that the last departure for tramway is at 23 hour and 11 minutes. Okay. Thursday, there is a gala dinner in the Château de la Pigossière, and we go there by bus, and the bus departure is at, as you see, 6:30, meeting in front of the Congress Center. In fact, it's not really in front of the Congress Center because the bus cannot stop in front of the door. So it's on the left, about 100 meters on the left, where you could see the bus to go to this castle. And then we come back by bus at 22 and 30 minutes. Concerning the technical visits, the first visit, wind tunnel of the CSTB and the swell basin of Central Nantes, the visit is full, and you see that the bus departure is at 2 o'clock, again in front of the Congress Center. And for technical visit 2, 3, and 4 and 5, there are still some places. And again, bus departure for the technical visit number 2 tomorrow morning at 9 o'clock. For the technical visit of the Saint-Nazaire Bridge tomorrow, the bus departure is at 8:30. So note that, and with a return by bus at 12. For the technical visit of the Cheviré Bridge, bus departure at 2 o'clock in the afternoon, and return at 5 o'clock. And finally, the technical visit for the new railway station of Nantes, which is a station made of ultra-high performance fiber reinforced concrete. The participants walk, though there is no bus. It's very close to here, and so participants walk to the train station. There is an application on smartphone named IABSE Nantes with the code that you see on the screen. Coffee breaks and lunches are served in the commercial exhibition space. And the opening and closing ceremonies, as maybe you saw, are filmed. And a lot of photos also are taken during the 3 days. And to finish all these informations, I would like to say that the next sessions are beginning at 10:30 in the 8 rooms, as you saw on your program. So now I close this opening ceremony. I thank you for your presence, and I wish you a good coffee break now.